We've pulled into Huntsville, Alabama in the Volt in late January. The weather's not bad, it's a little bit overcast, and we're at a soccer field. No, sorry, we're not at a soccer field. We're actually at GATR Technologies. Paul, welcome to the Drive for Innovation. Tell us what we're looking at here.
Well, what we're looking at is an inflatable antenna that packs in a small box, and it actually inflates, points at a satellite, and gets you an internet connection in a matter of about 20 to 30 minutes.
Now this is a big one right here, but you make them in at least 3 different sizes, or you will pretty soon be making them in 3 different sizes. But before we get to that, what's the rationale for this type of design? I mean, we get the idea about having more portable communications, but why a big soccer ball?
Why a big soccer ball? Well, the reason why is that this whole antenna is made out of a flexible fabric, and you want to be able to package something really small, and so by making it out of flexible fabric, it will collapse down into a small bag that fits in this box. So you can get this really, really big antenna, but packaged in this little bitty box. And so that's the value of the technology and the uniqueness of the technology.
Now you're working on one that's going to go in a backpack, which is mind-blowing enough as it is. This, I think, shrinks down into 2 boxes?
Yeah, this is in 2 cases, and it's transportable, and they're about 70 pounds apiece with the antenna and the electronics as well. In the backpack version, the whole system and terminal will fit in a backpack, so you can carry it on a plane, or you can, hike it up a mountain and do a high data rate communications link anywhere you are.
And what's cool about this one is, well, we're not getting any love from nature right now, but you're running this, you're running the pump, and you can run the electronics off a solar array that's lying on the ground.
Right, we have about 4 solar arrays that provide about 300 watts, and that 300 watts is enough energy to power a laptop, the communication link, and also the antenna.
You're a mechanical engineer, right?
Yes, yes.
How did you come up with this idea?
Well, for years and years, I worked with another gentleman in space deployables, trying to make really big structures in space. And after working and developing ways of making really big, accurate systems, I was able to come up with a way of making this on the ground. And we thought, hey, that's pretty cool. So we patented that, and we've been working on that ever since.
We're doing this outside because the satellites are out here, but also because it's a little bit windy today. And as you can see, these devices are anchored just to the ground. They can't move a lot, and they're not moving a lot. The design behind that is amazing to me. Talk a little bit about the whole stability issue and the tolerance factor.
Well, most people, they think that, you say you have an inflatable structure, that it's going to blow in the wind and it's going to move. And that's in fact not true for this antenna because it's round, and so the wind sort of goes around it, and as long as you hold it down properly, it's very, very stable in the wind, and this can withstand winds up to about 70 miles an hour.
70?
Yes.
70 miles an hour.
Our first antenna was deployed in Hurricane Katrina in 2005, so that was this first field experience where we actually saw the value of the technology.
And since then you've been in a lot of different places with working with NGOs, working with the military. The setup time on this is less than an hour?
Yes, it's less than an hour, and typically we usually can set up and be on the network in about 30 minutes for skilled operators.
What about non-military uses? How is it being adopted in other areas?
Well, this antenna is being used by a number of non-government organizations in humanitarian aid relief. So the World Food Program actually uses this to come into a site like in Sudan to set up a network communication for aid workers if they come in and are distributing food for logistics, things like that, and also their actually communication link back to their offices. And this actually fits in a plane and can be deployed in these remote places, and that's what makes it so unique.
And you can run it off a relatively lightweight, portable solar array that you just roll out.
That's right.
How much power does it take?
This is taking about 120 watts. So if you have a 300 watt electrical array, you can charge your battery and then also run your satellite terminal and also a laptop or 2.
So people are going to wonder, a bird comes, you get a bird strike, you get a little hole in it, you're screwed, right?
Right.
But you're not.
No, this has a blower that runs continuously, so we can actually, if we had a bird we could throw at it, we could actually, put a hole in the antenna. It would continue to inflate it. It'll actually work with holes in it the size of bullets, ironically.
And so, and the electronics adjust, right? It feels the fact that you're losing a little bit of pressure,
right.
so the pump will adjust
right.
until you're not using it, and then you patch it like a tent or
right.
a sleeping
Yeah,
bag.
we have a patch kit which consists of a piece of tape, and you can tape over it, and you're good to go.
Amazing.